So, one application, for example, one application is the electron diffraction pattern, means I am giving you an experimental idea. So, electron diffraction pattern, you will have a central spot and then you will have several other spots. Let us say this is your electron diffraction pattern which you got. This was the film where you are recording the diffraction pattern. What is happening is the electron beam is coming from top somewhere, from the electron gun, and your sample is somewhere here. Which is crystal. So, you can give the beam direction, that in the crystal what direction the X-ray the electrons were passing. So, that beam direction in the crystal will be UVW. And each of the diffraction spot, you know from Bragg's law, is coming from a plane. So, the indexing of the diffraction spot is in terms of the plane HKL, and here also you can show that Bragg's law will be satisfied only if the beam direction and the plane, the spot, satisfy the Weiss-Jones law. So, you will always in electron diffraction pattern, you will have HU plus KV plus LW is equal to 0, where now HKL is your diffraction spot and UVW is your beam direction. So, here we are not going into that sort of experimentation, but let me just show you a quick example of what we did last time. So, redoing line of intersection of two planes. Let us take up exactly the same problem. So, this is one of the things, the another geometric application of Weiss-Jones law. Two applications of Weiss-Jones law: if two planes are given, you can find the common direction. If two directions are given, you can find the plane passing through the direction. So, remember that we had a, we geometrically drew in within the unit cell, we were given two planes 1 1 1. So, we drew the 1 1 1 plane, and then we had one bar 1 0 direction 0 plane. So, two planes. So, for 1 bar 1 0, so we took the origin there 1 bar 1 1 bar 1. Our axis system is x, y and z. So, if I choose the origin here, one along x, one along y and one along z. So, I get the red plane 1 1 1. If I choose the origin here, 1 along x is this, minus 1 along y is that, and 0 means in parallel to the z axis. So, my plane is like this now. So, these were the two planes, and there by our visualization we saw, by our drawing or construction, that this is one common point, this is another common point. So, this was the line of intersection, and then we just indexed it by, let us say, choosing the origin here. So, we index it half along x, half along y and minus 1 along z, half minus 1, which we said by multiplying by 2 the direction was 1 1 2 bar. You can use Weiss-Jones law to verify your result. Okay. If this direction is the line of intersection, it should be lying on both the planes. So, it should lie on 1 1 1 as well as it should lie on 1 1 bar 0, and you can quickly see that that is true, because 1 into 1 plus 1 into 1 plus 1 into minus 2 is equal to 0, which shows that 1 1 2 is lying in 1 1 1 plane. And with the second one, 1 into 1 plus minus 1 into 1 plus 0 into minus 2, that also gives you 0. So, that is a check on a geometrical answer that we have not made any mistake, we are on the right track. However, there was this drawing at all was not required. We could have taken a purely algebraic approach. So, there we will say, let, since we want to find the line of intersection, let u v w, we do not know, we want to solve that, let u v w be the line of intersection of 1 1 1 and 1 bar 1 0. So, line of intersection means the line should lie in both the planes. So, I should be able to apply the Weiss-Jones law. So, u v w lies in 1 1 1 because it is a line of intersection. So, this gives us u into 1 v into 1 w into 1 is equal to 0 by Weiss-Jones law, u plus v plus w is equal to 0. But since it is a line of intersection, it lies in the other plane also. U into 1, v into minus 1, w into 0 is 0. So, u minus v is equal to 0. This is also by again the second application of Weiss-Jones law. So, I can as well write this as u equal to v. I can substitute, once I have found that u and v are equal, I can use that in 1. So, substituting 2 in 1, we have u plus w is equal to 0, which gives w is equal to minus 2u. So, from 2 and 3, 2 and 3 what do I get? The line of intersection u v w. U v w was our line of intersection. 2 established that v is u. So, for v I write u. 3 establishes that w is minus 2u. So, I write u minus 2u. So, I have got everything in terms of u, thanks to the God given rule that I can divide by any common factor. U is the common factor now. So, the same direction can be written as 1 1 bar 2. So, in this process there was no need, means I did not even picture where is my 1 1 1 plane, where is my 1 1 1 bar 1 0 plane, and where is my line of intersection 1 1 2 is coming, just like a computational exercise I am getting. So, I am getting the answer. So, it is a good way to get an answer. It means if you are writing a computer program to handle any such crystallographic exercise, you will write like this, because computer can't do the geometrical visualization which you were doing to find the line of intersection. But as beginning students of crystallography, I will recommend that actually whenever such exercise comes, you try to do both ways. Okay. This algebraic method will always succeed. Geometrical method will require a little bit of more visualization drawing, but here you see with respect to the unit cell I am able to actually see 1 1 1 plane, 1 bar 1 0 plane, the line of intersection coming this way inclined. So, that develops your visualization skills and intuition, because 3-dimensional visualization skill is very important in crystallography. If you want to do crystallography purely algebraically, that's the a hard way. You can, but and sometimes it may appear simpler also, that why draw all this and why visualize, just compute numbers. But you should try initially, at least till you become quite familiar, you should try both ways.